Hello friends, my name is Mohan Amaravati. I am from Sri Venkateswara College of Engineering, branch Information Science and Engineering. Subject name Data Structure and its application. In that, I will explain the detail about the three topics: additional list operations, space matrices, double linked list. Additional list operations I will explain detailing. In that, we know about traverse, insertion, deletion, search, and sort. Traverse means accessing each element of a linked list, adds a new element to a linked list means insertion. Deletion means we all know about remove the existing element in that linked list. Search, find a node in that linked list. Sort the nodes of the linked list. This is all about the additional list operations. Now we can explain about detail one by one about traverse, insertion, deletion, and search and sort. About traverse a linked list, displaying the contents of a linked list is very simple. We keep moving the temp node to the next one and it display the contents. When temp is null, we know that we have reached the end of the linked list, so we get out of the while loop. So here of the we'll make a one while statement. So it is a small code about the traverse structure node into temp is called to head. If we print a list elements are while temp is not equal to null, print temp is greater than the given data. So temp is gives rise to temp is greater than the next. We can see about next. Insertion, we can insert a element in middle order or beginning order or a end order. Insert at the beginning, allocate memory for a new node, stores the data, change next of new node to point to head, change head to point to recently created structure node into new node. So this is small code about the insert the elements to a linked list at a beginning level of the adding the elements. Insert at the if we insert a element at the end, we can say that it also stores the data traverse to last node, allocate memory of a new node or for a new node, change next of a last node to recently created node. Recently created node is going to change the next node when if we put a element at the end of the linked list. So this is also about small code about a insert a and insert at a middle. If we add an element at a middle order, we will say about changing the next pointers to include a new node in between and allocate memory and stores data for a new node, traverse to node just before the required position of new node. And for this also we have a code of dynamic memory allocations use of it means malloc. In that we will say the size and structure of a node. In data types we can take a integer is to 2. If integer is lesser than of the position, we can say the next node of a head. Delete from a linked list, you can delete either from a beginning, it is also same, but in insertion we will add, but in delete we will remove the existing element which we insert a element in linked list, so that one we will remove the element. If we come over the deletion, delete from beginning, point head to second node, delete from the end, structure node into temp is gives us to head, while temp is greater than next and next is not equal to null. So this is also says about the its end of, if we remove the end element it shows like this. Delete from the middle, if it deleted the element from the middle, traverse to element before the element to be deleted, change next pointers to include to node from the chain. Search an element on a linked list, you can search an element on a linked list using a loop using a following steps. We are finding it item on a linked list. Make head as the current node, run a loop until the current node is full because the last element points to null. In each iteration, check if the key of the node is equal to item. If the queue matches the item, return true, otherwise return false. It will give a true or false if we search an element on a linked list. So bool search node structure node into head reference gives rise to int key while current is not equal to null if current is greater than the data key and it returns true. So it will take for the next step. Sort elements of a linked list. We will use a simple sorting algorithm using a bubble sort to sort the elements of a linked list in ascending order below. Make the head as the current node and create another node index for a late user. If head is full, it will take a return, else run a loop till the last node is gives rise to null. In each iteration, following the steps of 5 to 6 steps, we will take a sort of the element of a linked list. Store the next node of current in the index. Check You will check if the data of the current node is greater than the next node. It is greater. Swap the current and go to the index. So this is about the sorting the linked list after deletion, insertion and traverse. So we will sort the linked list like this code. Next topic, space matrices. A space matrices is a special case of a matrices in which the number of zero elements is much higher than the number of non-zero elements. So we can clearly say rather than zero it should be smaller according compared to zero it should be smaller, and as a rule of thumb if 2 by 3 of the total elements in a matrices are zero it can called be as a space matrix. This is a definition of space matrices. So we can see some example, a small example is to 0 to 3 row and 0 to 3 column means 0 1 2 3 row, 0 1 2 3 column, 4 rows 4 column. Space matrices representations can be done in many ways. Following are two common representations: array representation and linked list representation. Method 1, using arrays. 2D means two-dimensional array is used to represent a space matrices in which there are three rows named as row, column, value. In that we can clearly say row is equal to 0 0 1 1 3 3, column 2 4 2 3 1 2, and value is to 3 4 5 7 2 6. Method 2, using linked representation of space matrices. Row, column. Index of row where non-zero element is located. Index of row where non-zero element is located. Value of non-zero element located at index. Next node, address of the next node. Next node gives rise to it will address as the next node. Linked representation of space matrix. It is a representative of space matrix where linked it will link the representative space matrix row column value of next node. We can start from 0 2 3 0 4 4 1 2 5 1 3 7. This is a start. Null is 3 2 6. Doubly linked list. This is the last topic of this concept, and a double linked list is a represented using the linear arrays in memory where each memory address stores three components: data value, the memory address of the next element, the memory addresses of the previous element. Okay, in this double linked list we can store the three components. First one, the data value, the memory addresses of the next element, the memory addresses of the previous element, and data value. This three components we can see in double linked list. Here you can see the starting and ending point of a double linked list. Advantages and disadvantages of double linked list over the single linked list. The delete operations in double linked list is more efficient. If a pointer to the node to be deleted is given, we can quickly insert a new node before a given node. In a singly linked list, to delete a node, a pointer to the previous node is needed. To get this previous node, sometimes the list is traversed in double linked list. We can get the previous node using the previous pointer, and a double linked list can be traversed in both forward and backward direction. This is about the advantages, and now disadvantages. Every node of double linked list requires extra space for a previous pointer. It is possible to implement double linked list with a single pointer throw. So all operations require an extra pointer previous to be maintained. For example, in insertion, we need to modify previous pointers together with the next pointers. For example, in the following functions, for insertions at different positions, we need one or two extra steps to set the previous pointer. Application of double linked list. After advantages, definition, and three components and disadvantages of application of a double linked list, now we can see about applications of double linked list. It is used by web browsers for backward and forward navigation of web pages. Least recently used, most recently used, catch are constructed using double linked list. Used by various applications to maintain, undo, and redo functionalities. In operating systems, a double linked list is maintained by thread shoulder to keep track of processes that are being executed at the time. Double linked list. Node 1 it start and node 4 becomes null to null. In double linked list is likely a single linked list, only it has the previous pointer, means we can say a single linked list only if we point its previous pointer. Representation of double linked list. Structure node. Prev means previous node, address of the previous node, and data item next into next addresses of the next node. We can see there is also null, and after output also null. So first one head goes to A, and next to B, and next to C, and next to D, and it will go previous also D to C, C to B, and B to A, and last also it will null. Starting head and goes to D, it will null, and it will, while it coming back to reverse, it will say also null. So this is about the representation of double linked list. Thank you guys. We will see you in next video.